IR, a passive infrared sensor. PIR sensor is an electronic sensor that measures infrared IR light radiating from objects in its field of view. They are most often used in PIR based motion detectors. So can use as a motion detector for a security system or a robotics. And what is the features of the PIR model, or what is the specifications of PIR model? So the supply is a 3.3 volt DC to 5 volt DC, and also the detection range is 6 meters. Also the output and detecting motion passive. Infrared sensor also are used for motion detection system, and LDR sensor are used for outdoor lighting system. So this is on general the application of IR sensor. Where we apply IR sensor, as you know, IR sensor applied in a lot of fields, but I will give you here the most important fields we apply. The first one, radiation thermometer, and also flame monitors, and moisture analyzers, gas analyzer, IR imaging device. And that's all I have about IR sensor.
Commercial sensors. What is commercial sensors? Are the use of component in array of products such as medical diagnostic equipment. This application requires a high degree of sensitivity. The resolution enabling temperature accuracy down to 10 degrees or less. And the temperature operation is about -20 to 70 degrees. The sensing capability for temperature to monitor building energy consumption, and the lighting control using motion to perceive people being present. One of the commercial sensor is optical sensor in pulse oximeter. Pulse oximeter is a state-of-the-art non-invasive method for determining the percentage of hemoglobin saturated with oxygen, an important measure when administering anesthesia, determining the effectiveness of the respiratory system, or diagnosing various illnesses such as pneumonia, pleurisy, and asthma. Hemoglobin that is carrying oxygen absorbs light in the IR region of the spectrum. Hemoglobin that isn't carrying oxygen, deoxyhemoglobin, absorbs visible red light. In pulse oximeter, a clip containing 2 LEDs and the light sensor is placed on the patient finger. The clip is connected by a cable to a microprocessor unit. The LEDs are rapidly and sequentially pulsed, and the detector is synchronized to capture the light from each LED as it is transmitted through the tissue. A photodiode has been the light sensor of choice in the past, but there is growing interest in using either the light to voltage or light to frequency converter. When using photodiode, considerable effort is placed into shielding it from noise. The next commercial sensor is integrated color sensor in blood glucose meters. Most diabetics test their blood sugar level at least 3 times a day. Accurate and reliable results are top priorities when a diabetic chooses which blood glucose meter to use. Other factors consider a size and weight, cost of the meter, cost of the test strip, ease of use, and a minimum sample size required. Fingertips provide an ample supply of blood for testing, but hurt more than other parts of the body when poked. A meter that lets you test with a smaller quantity allows the sample to be taken from a less sensitive place such as arm or thigh. The desired measurement depends on how the test strip chemistry is designed to reach with the blood sample. It might want the reflect of the particular wavelength of light, which can be achieved by either limiting the light source to only that wavelength or by filtering the sensor to see only the wavelength of interest. There are advantages and disadvantages to both of these approaches. Limiting the wavelength means that more is spent on the LED to get a particular wavelength output, but it allows to use a general purpose detector. Filtering the sensor let use a less expensive light source and spend more on filter detector. That's all about the commercial sensor.